Hello, this is Brett from Survivalcomms. On the bench today, we have an Optoelectronics R-10 Interceptor receiver. This device was produced in the 90s and is a near-field RF receiver that demodulates FM signals. Now, this device is truly a near-field receiver, and it's not designed to be very sensitive. It's much like a legacy technical surveillance countermeasures receiver, also known as a bug detector. One thing this device did excel at was receiving the input side transmissions of an analog cell phone or a two-way radio almost immediately in the near field. Now, how this device does so is by incorporating a comb generator in its mixer stage in lieu of a fixed frequency local oscillator. This allows the device to instantly lock on any transmission between 30 megahertz and 2 gigahertz in its receive range. This also is why the device by necessity is limited in its receive range. Now, if I remember correctly, the antenna input does go straight to the mixer, and its range can be extended with careful amplified pre-selection of the input, but this of course limits the signal range to the pre-selector range. Now, if we look at the front of our device, you can see that it's got an LED measurement of deviation, and there's a switch on top that switches it from 1 kilohertz to 10 kilohertz of deviation, and when you flip the switch, it goes from 10 kilohertz to 100 kilohertz of deviation measurement. And I don't know how accurate that is. We're going to find out. We'll test it with a signal generator. And then you have a signal strength graph right here, and you have a forward-firing speaker. It's pretty doggone simple. Antenna input is a BNC. It looks like this is likely a UHF antenna that came with it. And on top, you have your deviation switch. This allows you to skip whatever it's locked on. The volume control, potentiometer, and on-off switch are incorporated here. And then we have a squelch control here. And you can see that we have a power indication when we turn it on, a earphone or headphone jack, and then our lock indication LED here, and again a BNC connector. The housing itself is of an aluminum extrusion, which is good because it makes it nice and durable, and this device is in very good shape as far as the physical package itself. If we look on the left-hand side of the housing, you can see that we have our power connector here, and it's just a standard 2.1 by 5.5 millimeter barrel connector. And what I've done on this, because of the depth of it in there, is I've removed a little bit of the material from the side of it, and I can plug it into a power supply just like that. And we've done that for testing. Well, now that we've wrapped our heads around the basic principles of operation to a degree, let's take this apart because I need to replace the internal battery pack. At the bottom of our device, we have 2 Phillips screws and an aluminum plate. And we also have this one at the top right here. What we're going to do is we're going to go ahead and remove both of these screws. After removing both screws, let's go ahead and remove this plate from the bottom and set that aside. And you can see our internal battery pack right here. Let's go ahead and pull it out. And it should be adhered to the inside of the housing, but that doesn't seem to be the case anymore with this servo tape. And this should just slide out. We can separate our housing now and look at our device itself. Looks like we have a couple different boards, like a control board right here, and then our main board. We can see our LED bars here. All right, for laughs, let's go ahead and get this little control board out of the way here. So now that we've removed our switchboard, we can get a better look at this main board here. And what's interesting is looks like they have removed all of the details from every one of these ICs in here, probably to protect the design. And this right here looks like a modification. You can see this resistor between this IC and this IC here. Well, while we've got it apart, I'm going to go ahead and do some cleanup of the controls with some deoxit, and we're going to put a battery in it, charge it up, and we'll take it out and play with it. Now we remove the LED board, and there is a machine screw that's in here that hooks to the standoff on the other side and holds it in place. Reassemble our LED side. There is a small plastic spacer here that goes between the board, and when the screw pulls down against itself, this right here bears up against or between the two boards and allows that screw to reside in there without damaging this board and having a very solid mounting surface. So we need to reinstall that. The difficulty is trying to hold it in position. You could use a hemostat if you desire to do so, to slide it in there. Or what you can do is you can take a little bit of silicone grease and just put a dab of silicone grease on there and place that in place, and that will hold that in place while you're reassembling that board. These little pins were awful corroded here, or these sockets were awful corroded, as well as these pins, so I've cleaned them up and I've dropped some deoxit into these slots as well. Now just drop your screw through, and on the opposite side you can see where it protrudes through the board, and you will take your standoff and attach your standoff here. Bring it down like that, and then obtained a replacement battery pack, and I got one of these off of Amazon. I think it was like 18 or 19 bucks. But I am going to have to take this connector off of this old pack and place it on this one. Now, one of the sad realities of allowing a depleted battery pack, even if it's a NiCad, to stay in a piece of equipment that isn't used for a long time, is you can see this corrosion here. So trying to reuse this connector is not going to work out. It's my experience, even if I cut it up to here, which let's go ahead and try that right now and see if that corrosion still exists in this wire. But you can see solder's not going to stick to that. I mean, we're not going to have any luck flowing solder into that conductor there. And sometimes the further up the wire you go, you have good luck. And in this case, you can see there's less corrosion than what we saw at the end, but solder is likely not to flow into that joint. So place a lot of flux on just like that. And let's see if we can get it to tin up. If we can, we'll just stab in another piece of black wire. And as you see, solder's not going to stick to that wire. So we're going to end up having to replace this connector in this piece of equipment. So what I'm going to do is I'm going to remove this existing connector and install this JST connector and install this end on the battery. And this will provide me with a good detachable battery solution. Failing having some kind of connectors, it's certainly possible to go ahead and direct solder these wires in there. Something I want to let the viewers see if they're ever in this circumstance where they're having to reconnectorize one of these flat battery packs or things of that nature, and you don't have any heat shrink that's small enough to fit over top of these individual conductors. Whenever I wire one of these packs, I always offset the ground in positive connections and tie them together, and then slide the heat shrink, which is 3/32 glue line heat shrink, over top of both of the conductors. That way I can bring these both down like this right here, and it will cover both of our junctions, and it makes a very, very strong connection. As you can see, that's not going to go anywhere. Let's remove our old connector. So we've attached our new power connector, and we've got our battery pack servo taped up so we can put it back inside the housing. So after servo taping your new battery pack in place, you're going to need to go from the top down to reinsert your radio. So these boards are going to slide in these slots here. So just take your time putting it back together, and it's going to be awful hard to do this on camera. So I'll be back in a sec. So we've reinstalled our boards, and you can see we've got our power connections made. Now let's go ahead and seal it back up and test it out. So let's test the device with a signal generator. So I've got it set for 3 kilohertz of deviation FM, 1 kilohertz tone. And right now we're at negative 20 decibel milliwatts. Now, according to the original specifications for this piece of equipment, the sensitivity of the device in this frequency range should be around negative 40 decibel milliwatts or better, which is not very good. So let's go ahead and see if it meets its manufacturer's specifications. So we'll go ahead and we'll turn our signal on now. And you can see we've got a strong signal on our indication, and you can see our deviation is right in the 3 kilohertz range. So that right there seems to be accurate with a constant signal such as this. Now let's go ahead and decrease signal. Now we're at negative 30 decibel milliwatts. And now we're at neg 40. Neg 50. Neg 60. And we're dropping down. And neg 70, we're no bueno. Let's go ahead and increase it and see where we can come up with a sensitivity figure here. Okay, so neg 65, and that's open squelch, seems to be around the range that we are starting to lose our signal. Let's do a little testing outdoors with our Optoelectronics R-10. We're going to compare range performance to a contemporary scanner featuring close call technology. This is the Uniden BCD436HP. Our test transmitter is a radio that I'm becoming quite fond of, and this is the Tate TP9900.
Rampart, come in Rampart. This is Squad 51. Rampart, this is Squad 51. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rampart, come in Rampart. This is Squad 51. Rampart, this is Squad 51. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rhinoceros, this is Platypus. I am marsupial at this time, over. Rhinoceros, this is Platypus. I am marsupial at this time, over.
In our comparison, the Uniden BCD436HP outdistanced the R10 by several hundred feet off camera, which I anticipated, and you can see the lock times in my low RF environment here were extremely close. The audio of the BCD436HP was superior to that of the R10, and the sheer amount of data and ability to demodulate digital voice is extremely useful. Now, I realize this wasn't an apples-to-apples comparison, but 30 years ago, the R10's capabilities were state-of-the-art. Now, let us study an example where the R10 outclasses a contemporary close call scanner, detecting and locating small signal transmitters in the very near field. So let me demonstrate this for you. We have a small FM transmitter that's right behind our R10 interceptor right now. It's putting out 0.05 of a watt at this time, and you can see that our device is not picking it up at all with the loop antenna, and
As we change position, you can see that we're starting to pick it up. And as we turn it, you can see our bar graph go up. And now we go ahead and null it again. So in finding a very low powered FM transmitter in a small space, this would be a very good device for that. So let's compare that to our Uniden scanner with close call functionality, and I'll give you an idea what we're talking about, how the strength of having an insensitive receiver is good in some circumstances. So let's go ahead and turn on our low powered transmitter, and it's already identified our signal, and there's absolutely no way to null it. Let's go ahead and remove the antenna and see what happens. And as you can see, even removing the antenna hasn't really reduced our signal. So it's easy to see that the less sensitive receiver of the R-10 coupled with the superior build quality allowed this device to function effectively in a basically high RF environment or in close proximity to a transmitter, whereas the Uniden, even if you placed attenuation on top of it or internally, the signal is just penetrating the chassis of the radio, and that's just the nature of the beast. Well, if you made it this far into my content, thank you for watching, and I hope you found it useful. I hope this helps. This is Brett from Survivalcomms. Until next time.